All right, Kinesiology 2000, Coach Ken here. Welcome to Module 4. I'll have all of our grading complete for Module 3 by the end of the day Wednesday, but I wanted to make a short video just going over the expectations as we progress into this week's discussion and the assignment. So for this week's discussion post, you have to make sure you are performing 2 field tests on 2 clients of your choosing for VO2 Max. You need to perform 2 separate VO2 Max field tests for each client, so you can't use the same test for each client. In your writing, you have to compare your results for each client against the normative values, and you have to make suggestions for additional field tests you'd like to perform on each client. In your writing, you also need to make sure you're using at least one peer-reviewed article to support your statements throughout your post. Now, when we go into this week's assignment, you're going to have to perform calculations. Just for reference, I'm using the 8th edition of this textbook. So I'm going to give you some page numbers inside the book that will help you along as you move into Module 4. Okay, so I don't think we'll have much of an issue with questions 1 through 4. However, when you get to question number 5, you have to calculate the energy cost of each workload. So there's 3 stages of the workload using the ACSM leg ergometry formula. Now, using the 8th edition of the text, you can find that on page 88 in table 4.3, and the name of the table is Metabolic Equations for Measuring Gross VO2 Max. So for stage 1, you want to use the value of 180. In stage 2, you want to use a value of 360. And in stage 3, you want to use a value of 540. Now, your equation for calculating this gross VO2 max is your work rate divided by the body mass times 1.8 plus 3.5 plus another 3.5. So for example, for stage 1, you'd go VO2 max will equal 180 divided by body mass, which is 82 kilograms, times 1.8 plus 3.5 plus another 3.5. Now, once you get that value, you want to look on page 89, and on page 89, you have the paragraph converting units of measure. So you have to take the value that you calculated and you need to convert that into METs or METs. And the way that you do that is you divide that value that you come up with, you divide that by 3.5. So whatever number you get for stage 1, you divide that by 3.5. That'll give you your answer in METs. You do the same thing for stage 2, and you'll do the same thing for stage 3. So for question number 6, you need to calculate John's VO2 max using a method known as the multi-stage equation. You can find the multi-stage equation on page 102 in a section called the multi-stage model for estimating VO2 max. Now, while you're calculating this, you're going to use values that you have from question number 5, and you only need to use the heart rates from two of the 3 stages. And you want to select the 2 stages that have a steady state heart rate between 115 and 150. So you're only going to need 2 of the 3 stages in order to calculate these values. You also need to calculate a value known as the slope. Now you can see the slope under the paragraph multi-stage model again on page 102. I'm going to give you the value for slope, but in your calculations you have to show how you arrived at this number. So your value for slope is 0.21. Again, your value for slope is 0.21, but using the equation on page 102 in your text where B equals slope, you're going to plug in the numbers from the equation, and you're going to arrive at or calculate how we arrived at 0.21 in order to receive credit for this. Also, once you get your values for slope and you plug in 0.21 everywhere you see B in your multi-stage model for estimating VO2 max. Once you get your values, you need to convert that number into METs. And how do we do that? By dividing by 3.5. Okay, in question number 8, you have to use a formula known as the Carvonen method to calculate the target heart rate zone for John, so his minimum and maximum heart rate values. Now, the Carvonen method uses what's known as your heart rate reserve. So your heart rate reserve is the difference between your maximum heart rate and your resting heart rate. Now, you can find that on page 133 under the heart rate reserve method. So in question number 7, you have to calculate what John's fitness classification is. So anywhere between poor to excellent, seen in table 5.1, the comparison of methods for prescribing exercise intensity for healthy adults. So once you identify his fitness classification, you'll use the percentage of the heart rate reserve, or that second column, and you will take the first value and you'll take the second value. The first value will be your minimum heart rate, and that second value would be maximum heart rate. For example, if you determine that John's fitness classification is good, your minimum value would be 65% of the heart rate reserve, and your maximum value would be 80% of the heart rate reserve. Question number 9, we need to figure out how long John needs to cycle in order to burn 100 calories. Now, you can find this on page 136 under time duration of exercise. For this, you need to calculate 3 things. We need to calculate the gross caloric cost and the net caloric cost. Once you get the net caloric cost, you take the total amount of calories you wish to burn, which is 100. You divide that by your net caloric cost, and that will give you the time it takes in order to reach that caloric output. Word of advice: do not wait until the weekend to contact me regarding this assignment, especially if you're having trouble with the calculations and you need help talking through some of the questions. I understand some of you have jobs which prevent you from doing a lot of your work during the week. However, not being able to contact me is not an excuse to turn in late work for this assignment. The deadline is still Sunday night at midnight Central Standard Time, so make sure you allocate enough time during the week to work on your calculations for this module to avoid any penalties for late submissions. And that's about it. I want to wish you all the best of luck. Again, feel free to reach out to me directly if you need any assistance with this week's discussion post or assignment. I can't wait to see what we come up with. So until next time, I will talk to you later. Take care.